Hello, beautiful people, and welcome. This is part 2 of the videos we're doing on the practice quiz number 2. This is for the Integrated Math 1 class for Module 16. In part 1, we went through how to name things like a point, array, a line, and a plane. We ended up just briefly mentioning the distance formula, and so in part 2, we're going to pick up with question number 2 on how to figure out if two segments are in fact equal in measure. And then just to let you know, we are on campus, so if you hear a loud bell, I apologize in advance. Also, if there is an intercom going off, I also apologize in advance. I am also human, so if a mistake occurs, please let me know. And then that way I can correct my mistake and we can both learn from my mistake. All right, you guys. Let's get started. On number 2, it says determine the measure of each segment, then indicate whether the statements are true or false. So this question is a two-parter. First, it's asking us to determine the measure. Then it's indicating for us to determine if this statement is true or false. So in order to do that, we're going to start off with our distance formula. In video part 1, I kind of mentioned there's a song online, so go ahead and watch that video, and there's that song. But just to recap, our distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then we take the square root. And that is our distance formula. Now, in order to find out what our distances or the length, the measure of segment BC, I first need to know what my 2 points are. So B is, I'm looking here, and I'm actually going to just see where the location of it is. So B is at 1, 4. C is at 2, -1. And then we're also going to do that for, let me name it differently. Let's do, this is B, this is C, so we know which one's which. And then we have D. D is located at 4, 4. And C, we already know where C is. C is at 2, -1. Now, you will be using the distance formula twice for this. So let's get started. So let's do BC. So segment BC is equal to, and before I even do anything, I'm going to label. Here's x1 minus, let's start again. Let me even erase this or use a whiteout. Let's try this again. This is x1, y1, x2, y2. Singing that song in my head. It's messing me up. All right. x2 is 2 minus x1 is 1, quantity squared, plus y2 is 2 minus y1 is 4. And I just realized that y2 is -1. So I'm going to erase that. -1. So let me check that again. x2, x1, y2, y1. And again, quantity squared, then we take the square root. So now we're going to simplify. Parentheses first, we're doing PEMDAS. So we have 2 minus 1 is 1 plus -1 minus 4, -1 minus 4 is -5 squared. Now, whenever you square root a number, that number, not square root, whenever we square a number, multiply it by itself twice, your answer is always going to be positive because 2 is even, okay? Again, it doesn't matter what's inside, if it's positive or negative. When you square that number, because 2 is even, your answer is going to always be positive. So 1 squared is 1 plus 5 squared, or -5 squared, is 25. And that's equal to square root of 26. Now, depending on who your teacher is will depend on if you want to simplify this further. I actually want you to leave it because we are just trying to figure out if they are equal. Again, our question is segment BC equal to segment BC? So this right here is segment BC. We don't have to go any further. So now I'm going to do exactly the same thing for segment DC. So segment DC is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. Okay, so here's our square root. x2, let's label these. It should be a y. So x2 is 2 minus x1 is 4 quantity squared plus y2, this is a 2, y2 is negative 1 minus y1, which is 4 quantity squared. So then we're going to simplify inside of the equation, inside of the radical. So 2 minus 4, that is negative 2 squared plus, this is, how many negatives do I have? I have minus 5 negatives. So then I have negative 2 squared is 4 plus negative 5. So this means I have the square root of negative 1. Oops. And let me, oh, did you guys see that? Did you guys see that? That's wrong. I should have taken squared. That's not okay. Let's try again. Negative 5 squared is 25. And immediately, I'm already checking what I have. I have 4 plus 25 and I have 1 plus 25. So this is the square root of 29. And I have the square root of 26. So are these equal? For question number 2A, are these equal? No. So this is false. And that is because the square root of 26 does not equal the square root of 29. Okay, now we're going to do exactly the same thing for B. We're doing exactly the same thing for B. For B, they give us segment EF, and they give us segment AB. So we're going to say E is at, what's the position of E? Negative 4, 1, 2, 3, negative 3. And F is in the position of negative 1, 1. A is in the position of negative 4, 2. And B is in the position of 1 and 4. And again, our objective is to see if this statement that they gave us is true. And the statement that they said is segment EF is equal to segment AB. So again, we're going to use the distance formula twice. So segment EF is equal to x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then we take the square root. And I'm actually going to write the formula twice. Because we're using the same formula, we're just using different numbers inside the formula. So plus y2 minus y1 quantity squared, and then we take the square root. So then I'm going to label my points x1, y1, x2, y2, x1, y1, x2, y2. I'm kind of doing it both at the same time, but not really, just this part. So okay, segment EF is equal to, here's my square root, x2 is negative 1, x1, here's where you have to be careful. Sing the song in your head, x2 minus x1. So x2 is negative 1 minus x1 is negative 4. It's easy to get this mixed up and not have this double negative. Quantity squared plus y2 minus y1 quantity squared. Again, easy to mix up these two negatives. So then, since I have these two negatives, if you could circle them without crossing out any numbers, that means it's a plus. So I have negative 1 plus 4 quantity squared plus 1 plus 3 quantity squared. So here, that means I have, what is this, 3 squared plus 4 squared. So that means I have 9 plus 16. 9 plus 16, that's 9. So 6, 7, 8, 9, 10, that's 25. And we should all know that the square root of 25 is in fact 5. So the distance or the measure of segment EF is 5 units. We're going to do exactly the same thing here. So again, here's your square root. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so again, plus So I have 5 squared plus 4 minus 2 is 2 squared. So 5 squared is 25 plus 2 squared is 4. So I have square root of 29. So again, is the measure of AB equal to the measure of EF? In this case, I'm getting false as well. Because, and I'm going to just double check my work again. So x2 is negative 1 minus x1, y2 minus y1. This is 4. This is 3. 3 squared is 9. 4 squared is 16. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I'm just double checking just to make sure, because since both of them are in fact false. So EF, segment EF is square root of 25, and I'm doing that on purpose just so you guys can see that the square root of 25 is not equal to the square root of 29, therefore our answer is false. Now it's asking us what is the midpoint? Midpoint of DC. So what is DC? I'm going to show my work here. D is 4, 4. C is 2, negative 1. And again, our formula for midpoint is take your x's, add them, divide by 2. Take your y's, add them, divide by 2, parentheses, comma. So here we have take your x's, so 4 plus 2, divide by 2. Take your y's, 4 plus negative 1, divide by 2, parentheses, comma. So 4 plus 2 is 6, divide by 2. 4 and a minus 1, that is 3, divide by 2. Simplify. 6 divided by 2 is 3. Keep this in a form of a fraction. Don't simplify this, and you are done for your midpoint. Now, you can add equals capital M if you'd like, but make sure if you're using M for midpoint, it has to be a capital M. Lowercase means something else. All right, give 4 different names for the angle below. Now, there are different ways that you can name angles. Again, mathematicians are what? We're lazy. So we're not going to write the word angle when we can draw it. So we're going to say angle. You can say different things. So you can say angle JKL. You can say angle LKJ. You can also say angle K or angle 1. Now keep in mind that K, when using the 3 points, K has to be in the middle because it's the vertex. So it's this part right here, the bend. You have to indicate where the bend is, and the bend is at K, and it always has to be in the middle. If you're just using the bend, like you can just say K, or you can just say 1, and that's fine. So it's asking for 4 different names. Here they are. Right. Segment AB lies on the coordinate plane with A located at, here it is, it's located, and the midpoint of AB is 2, 3. Can you locate B? If so, find the location. Okay. So there's 2 different ways to do this. One of the ways is you can sketch this. The other way is you can use algebra. So I'm going to sketch this first just to give you an idea of what we're working with. So we have point A at negative 2 and 5. 1, 2, 3, 4, 5. Here's negative 2 and 5. We know that the midpoint is negative 2 and negative 3. Here's the midpoint. Here's point A. So we have this line. Let's see if I can sketch this. Both of them are at negative 2. So I have this line here, and we have a segment AB where M is the midpoint. So we're trying to figure out where's that point? Kind of like, where's that point? So here's the thing, you guys. So guess and check method in a way. Notice the difference or the distance between these two, and we can only do this because this is a vertical line. Okay, if it was diagonal, we can't do this. So because it's vertical, I can count the distance. So I have 1, 2, 3, 4, 5, 6, 7. So I know that, let me draw it this way. I know it's vertical, but I'm going to draw it horizontal. Here's A, here's B, here's M. We know that A, the distance between A and M is 7. Now, if M is the midpoint, that means if I take that segment and fold it in half, my two sections should be equal. So then we know that the distance here is 7 as well. So if I continue 7 jumps down, what would that point be? Now, I'm going to show you differently. We know that our midpoint formula is x, take your x's, add them, divide by 2, comma, take your y's, add them, divide by 2, and that is equal to your midpoint. So I'm going to call this xm for midpoint, comma, ym for midpoint. Again, capital M. Okay, we know that A is x1, y1. We know that m is xm, ym. Okay, so I'm going to substitute. So I have x1 is negative 2 plus x2, I don't know what that is, divided by 2. Y1 is 5. I don't know what my y2 is, but I'm going to divide that by 2. And that's equal to, I do know what xm is, negative 2. And I know that my y is negative 3. Okay. I did write this a little bit large on the larger side, so I'm going to use a separate sheet of paper. I know that xm is equal to my x1 plus x2 minus 2. The midpoint x value comes from this formula. I also know that my midpoint y value comes from my y1 plus y2 divided by 2 value. So you kind of have two different formulas. So you can say negative 2, which is your xm here. This is your ym. So negative 2 is equal to this first part, negative 2 plus x divided by 2. And then you can also say negative 3 is equal to the second part, 5 plus y divided by 2. And then you're going to solve. So I'm going to multiply by 2 both sides. So I have negative 4 is equal to negative 2 plus x. I'm going to add 2 both sides. So this is, what is this, negative 2 equals x. And then the same thing, times 2 times 2. This is negative 6 is equal to 5 plus y. I'm going to subtract 5, y is equal to negative 11. So my midpoint is, not my midpoint, my B point is at negative 2, negative 11. Now let's go back to our original way. We knew that it was 7 away, so if the midpoint here is at negative 3, this is negative 3, if I go down 7 more, would that give me what I need? So let's check. Negative 3, let me count. If this is negative 3, this should be 8. It's 7. 8. It is 8 jumps away. Let me say that correctly. This is 8, not 7. Stromades needs to learn how to count. All right, this is 8. So if we go 8 jumps, will that give me 11? And in that case, it does. It does give me negative 11, which would be all the way down here. All right, I'm actually going to skip numbers 6 and 7 and 8 because we need straight edge and compass, and we're going to do that on a separate sheet of paper with lots more practices than this. But definitely look at the question and know exactly what's going to be on your quiz. I'm going to pause the video recording right now. This is going to be the end of part 2. We're going to continue number 9 in part 3, where we are using transformations, our image, our pre-image, writing rules on how to do this. So make sure you continue watching in part 3.